Okay, so here we are at extending part 2 of proportional relationships and applying it to the real world. Remember, a relationship is proportional if it varies directly. So let's see what that looks like. In this situation, it says the total cost for tickets to the dance varies directly to the number of tickets purchased. So if 5 tickets cost $15, identify the constant of variation and write an equation. Remember what it said. Total cost varies directly to number of tickets. What this is telling us, ladies and gentlemen, is our total cost 2. That fraction bar is the word 2, okay? The 5 tickets. So when we think about this, our y is total cost, our x is number of tickets. So this here is my constant of variation. So I would say my constant is 3 per ticket. So I need you to write down that 3 per ticket is your constant of variation. That's what's consistently changing. That's the constant change, 3 per ticket. So now if we had to write the equation, y is my total cost, x is my number of tickets. So remember, it's y equals kx. Well, what did we just say k was in this example? We said it was 3, so therefore your equation is y equals 3x. Okay, let's go look at another one. The number of teachers varies directly to the number of students. Number of teachers directly to number of students. Right there, I know my y and my x. But if you don't know, let's keep going. If there is 1 teacher per every 20 students, identify the constant of variation and write an equation. Well, let's stop for a second. We know y goes on top, okay? And we said the fraction bar is that varies directly to, and then my x. So basically, it's in this problem, it says teachers to students. Go back and read the second sentence. It said 1 teacher per every 20 students. Okay? So 20 students per teacher. That's your constant of variation right there. Okay? So we said y is the number of teachers. X is the number of students. What did we just say my constant of variation is? 1 over 20. Therefore, this is your equation. Okay, let's try one more. In a car wash fundraiser, the money earned varies directly with the number of cars washed. If 4 cars are washed, 14 is made. How much money is made when 15 are washed? Well, it says money earned varies with number of cars washed. So money earned over number of cars washed. That was 14 over 4, remember? If I do that math, I actually end up with $3.50 per car. And I can do that this time because I'm talking about real world. It's money. 14 divided by 4 gives me $3.50. Make sure you put that 0 after the 5. That is your constant of variation right there. Okay? So remember, y is your total money. X is the number of cars. So if you did y equals 3.5x, that would tell you how much money you'd earn. Well, they told me I washed 15 cars. Remember what cars was? Cars was your x. So I can replace x with 15. I can multiply by 3.5. So I know I earned $52.50. That's the whole point of doing this, so that we can then plug in a value and figure out how much we might make or how much something might cost. So let's go. Here's number 10. I want you to try this on your own after I read it to you. The cost of apples is directly proportional to the number of apples purchased. Cost, directly proportional. Remember, that's the same as constant variation. Number of apples. Okay? Oops. So now, if 8 apples cost $2, determine how many apples were purchased if the total cost was $4.50. Okay, so first you have to find your constant of variation. Write an equation, then plug in what you know. So the last way you might see direct variation is on a graph. So it's important to understand that a direct variation equation, the y equals kx that we did last night and today, it's a special type of linear equation. Look at the linear equation, y equals mx plus b. Almost looks the same, right? But when something varies directly, the y-intercept is always 0. It always goes through the origin. And the slope is your k. So when you have a linear equation or linear function, okay, your slope is always whatever your constant of variation is, and your y-intercept is always 0. So let's look at these equations. If I look at 11, 12, and 13, all of them have a y-intercept of 0 because there's nothing there. There's no plus b, okay? So what I can look at then, if I look at number 11, my constant of variation is 4. That means I'm going to go up 4, right 1. There it is. If I look at 12, again, my y-intercept is 0 because there's nothing there. My constant of variation is 2/3. So I'm going to go up 2, right 3. I just graphed my line. Last, my y-intercept again is 0, which it should be for a direct variation. My slope this time is -1, meaning I'm going to go down 1 and right 1. And there is my graph. Okay, you need to write this down. A proportional relationship always goes through the origin. If it doesn't go through the origin, there's something different. It's not proportional necessarily. It can still be linear, but there's something different about it. There's a lot that's been thrown at you, and it's okay if you feel lost. But if you feel lost, ask. You can, when you submit this, make a comment. You can send me an email, or in class when we go over this, ask.